Hello everyone. In this video we are going to see one calculus problem and to explain how to solve it. The question says, suppose that a function satisfies this condition, so limit when, I'll just write it down, so limit when x approaches 2, f of x minus f of 2 over x minus 2 equals 0. And we have from a to e to decide which of them might be true, must be true, or can never be true. The first thing, a says f prime of 2 equals 2. So we need to see whether this can happen, must happen. Now, our condition, so let us actually see what is f prime of 2, or f prime of x0 is limit by definition when x approaches x0. F of x minus f of x0, x minus x0. Okay, so this is derivative at x0. Now taking x0 equals 2, we have what is given to us at the starting point. That means f prime of 2 equals limit x goes to 2 f x minus f of 2 x minus 2, and that's equal to 0. So f prime of 2 equals 0. Now, how can we argue? We can say that f prime is a function, so it can have only one value, only one output. Okay, therefore f prime of 2 cannot be equal to 2. So for a, we can conclude that it's wrong, it can never be true. So f prime of 2 equals 2 can never be true. Okay, so that's A. Let us see B. B requires some elaboration. So B says f of 2 equals 0. Now notice that apart from the condition that we have, we don't know much. So the idea here would be again to see if we can find a function for which f of 2 equals 0 and f prime of 2 is equal to 0 as well. Because remember, the first condition, so let us go to the task. The condition of the task says f prime of 2 equals 0. This means, if you know the geometric interpretation, there is a horizontal tangent at 2 to the graph of the function f of x. So this we know for sure. So this we know for sure. So certain thing. And now the question is, okay, when we have that, can this also happen? We will see that this can happen. So answer is, if you want to pause the video and try on your own to figure out how to find this function, you can do it, but answer is this might happen. We will see now. So I can give you, of course, immediately the function, but that's not the point of learning. So we can go step by step. And we will do this in 2 steps. So first, we will find a function that has f prime of 2 equals 0. So that must be a function that has, for example, a horizontal tangent parallel to x-axis. This is x, this is y. And that function can be something like this. Okay, so that can be this function here. So indeed, if this is 2, then we can say that this situation means f prime of 2 equals 0. Why? Because at 2 there is a horizontal tangent at 2, or in the neighborhood of 2. Is there a function similar? There is also a function similar to this, such that it has f of 2 equals 0. So this is f of 2, not f of prime. So that function means it touches x-axis at 2. So let's say this is 2. This is x, this is y. You can say that one of the ways to solve, and you can challenge yourself, is, for example, x minus 2 squared. So this function actually has the desired property, because if we take f of x equals x minus 2 squared, f of 2 equals 2 minus 2 squared, which is 0, squared, which is 0. So f of 2 equals 0. And also f prime of x is 2, x minus 2. So that f prime of 2 equals 2, 2 minus 2, which is 0. So that f prime of 2 equals 0 as well. This function is the solution of the problem B. We said this might happen. When the answer is that might happen, you have to find a specific concrete function, and that's here the function x minus 2 squared. I'll just highlight it so that you can see and notice. Great. Okay, let us look at C. C says is limit when x approaches 2, f of x equals f of 2. Again, for this question, we have to use A. We have to use A and the task. Now, the condition of the task, so C, the condition of the task. Says f prime of 2 equals 0. We can also say f is differentiable at 2. Now, is f, we know that differentiability implies continuity. So f is also continuous at 2, and that means limit when x approaches 2, f of x equals f of 2. So f prime of 2 means f is differentiable at 2, and f is then continuous at 2, and that means that limit when x approaches 2 of f of x is f of 2. So this means must be true. F of x is continuous at x equals 0. So looking at this function, so we can just say f prime of 2 equals 0. Does this necessarily imply that f is continuous at 0? The answer is it might happen, so it doesn't need to be true always. If you go back to this function here, so we'll just say not necessarily. So might happen, might not happen. And we'll just modify the answer of part B. So for might happen, look at B. So here it is continuous at 0, and the value is 4, so it can happen. But we can also modify that example, and we will keep it because it helps us. We can say, for example, the function doesn't need to be at all defined. Okay, I'll just put here 2. Okay, perhaps B. Okay, this is 2, and this is our f of x. And this here is, let's say, 1/3. So the function is not defined at 0, so it cannot be continuous at 0. This means f of x not continuous at 0 because it's not defined at 0. Okay, so there is no point of asking whether it is continuous. It's not defined, but the function indeed, it has f prime of 2 equals 0. This is correct. And even f of 2 equals 0 is correct. So you can always use, and you can combine the previous solutions. Okay, and the last part, which is part E, f of x is continuous at 2. Actually, we answered this, if you notice, at C. Here is, so this is E, also E, so E must be true. And that's it for this problem solving. I hope this helps a lot to see that some simple tasks require analysis. Thank you.